Today the topic of discussion is in singly circular linked list you will understand how to delete a node from middle, that is not from the beginning, not from the end, somewhere in middle, that is second, third, fourth, whatever it is. Prior to this we have understand how to create singly circular linked list, and in that we have studied menu. Then we have studied how to print element of linked list. Then we have seen insert, that is if you want to insert a node, and we have seen three cases in that, that is insert at the beginning, insert at middle, and insert end. After that we have started with delete, and in delete we have already seen delete beginning. Now our second job is to delete a node from middle, that is not from the beginning, not from the end, somewhere in middle. Fine, let's start. So you have a coding, and in delete also you have a function, you have a menu, that is for if you press 1 you will delete from the beginning, if you press 2 you will delete from the middle, if you press 3 delete from the end. What do you want to do? Since my job is to delete from the middle, I'll press 2, ch will have 2, switch will have 2, I'll jump to case 2, and in case 2 I'm calling delete mid function, that is I'm calling this. And prior to this you have a linked list which is something like this, where head is pointing a node having address 100 and value 5, tail is pointing a node having address 500 and value 9. Fine. So this is what currently the linked list is, and you have to delete any node from middle. Middle could be any node. Fine. Okay, let's see. So what you did what you have created a function delete mid, and there you have a pointer ptr and current, while you have current initialized with head, and the data type of both the pointer is node1. What is node1? I've already explained you, I will always explain you, and I'm trying, and I'm asking you to kindly see my first video, that is of create. So I've created a structure, name is node, having two part, one data and one is address. This address is of structure type, and I've created a variable of this structure which is node1, and by type defining it, this structure is represented by node1. Now this entire structure is represented by node1. So and what is structure is the data type, so this pointer is of node1 type and this pointer is of node1 type. Fine. So finally what you'll see, you have a linked list which is something like this. And what you want to delete, suppose you want to delete the fourth node. The moment you will delete the fourth node, what will happen? This current will not keep the address of this will keep the address of next node, because current knows that this node is leaving. Now I have to keep the address of next node. And what is this next node? This address of this next node is address of next address of this ptr. So let's see how this coding is working. Fine, let's start. So I've created a pointer ptr, I've created a pointer current, and I've initialized with head. What is head? 100. So current will come to the 100. Fine. Okay. I've created one variable I is equal to 1. I've created one variable position, that is pose. I'll ask the user to enter the position. So I've created a variable I is equal to 1. I've created a variable pose. Let me ask the user, enter the position to delete. Which node we want to delete? No, enter the position you want to delete. So suppose user want to delete fourth node. So the moment user will enter 4, the pose will have value 4. Fine. Okay. Now comes the question. This coding, and I've already explained you many times, and if you have seen my insert middle node, so I've used this same coding, and in delete also, in delete middle I'll use the same coding. While position is not equal to what is position for? While position is not equal to I plus 1, what is I? 1. So 4 is not equal to 1 plus 1. Yes, 4 is not equal to 2. Condition become true. I'll move inside and I'll update current. Current will have current next. What is current next? 200. So current will move from this place to this place. Fine. Okay, I'll increment I will become 2. Fine. I'll again go and check while loop. Is position is fixed 4, is not equal to, now I is 2 plus 1. Is 4 not equal to 2 plus 1? Yes, 4 is not equal to 3. Condition becomes true. I'll move inside. I'll update current will have current next. So what is current next? 300. So current will move here and it will move to 300 node, that is which is currently in front of you. Fine. I'll increment I'll become 3. Fine. Okay, I'll again move up and I'll check position. Position is fixed 4. Is 4 not equal to, what is I? 3. 3 plus 1. Is 4 not equal to 3 plus 1? 4 is equal to 3 plus 1. Condition becomes false. The moment condition becomes false, I'll come out. Now you can see that current is pointing to a node which is just behind the node which is to be deleted. Fine. So current is just behind the node. Okay. Now what I'll do, I'll make pointer to sit on the node which is just ahead of current. So PTR will have current next. What is current next? 400. So PTR will have 400. So PTR is a pointer. We have already created a pointer. So PTR will have 400. By this coding, PTR will have 400. So PTR will come here. Fine. So now PTR is sitting on the node which is to be deleted. Fine. Okay. Now I will ask PTR, kindly give me your address. Who will ask? Current. Current will ask PTR to kindly give your next address, because your next address is the address which now I will keep. So current next this will have PTR next this. So current next, which is 400, will have PTR next, which is 500. So here 500 will come. The moment here 500 will come, so this node will start pointing this. So this connection will break down. Fine. Okay. Now what will happen? I'll print on the screen element deleted is %d, and this %d will have PTR data. What is PTR data? 8. So my screen will show me element deleted is 8, and I will feel very good. Yes, 8 was my fourth node which I have to delete. So I'll feel good. I'll really feel good. And after that, what I'll do, I'll free PTR. Free is a dynamic memory allocation function which deletes the memory. So it will delete PTR. So it will delete PTR. The moment I'll free PTR, it will get deleted, and finally the structure will remain like this now. So this structure, in this structure, 8 is no more. 8 is no more, and this structure is looking something like this. So this was the coding of how to delete a node at the middle of singly circular linked list, which is exactly same as singly linked list.